Quebec's hydroelectric infrastructure, managed primarily by Hydro-Quebec, generates over 86% of the province's electricity through more than 61 hydroelectric generating stations and 681 dams. Quebec's engineers' ingenuity is proved through those massive civil projects. For example, the Daniel Johnson Dam is the world's highest multiple arc and buttress dam. Hydroelectric dams convert the kinetic energy of flowing water into electrical energy by routing water through turbines connected to generators. This process requires large reservoirs, altering river hydrology. However, projects like the James Bay Complex initiated in 1971 profoundly disrupted the environment and the Inuit and Cree community. Those consequences are still being felt today, decades later. The construction of large water reservoirs caused significant flood, destroying hunting ground, displacing communities, and disrupting ecosystems that were previously protected by the communities for generations. This can be retraced from the poor water circulation after flood. The mercury leaked is then present in vegetation, heightening the formation of methyl mercury, an easily absorbed form of mercury. The concentrations of methyl mercury increase as it passes through the food chain. Called bioaccumulation, it is a direct threat to the Cree and Inuit populations who depend on fishing as a primary food source.
Large hydroelectric dams significantly alter natural river ecosystems. When a dam is built, it actually blocks the fish migration routes and transforms rivers into slow reservoirs. This changes water temperature, oxygen levels, and also habitat conditions for the aquatic species. According to Fisheries and Oceans Canada, barriers such as dams can disrupt spawning cycles and reduce fish populations if mitigation measures are not implemented. In addition, turbines can injure or kill fish as they pass through generating systems. As a solution, engineers have created fish ladders, fish elevators, and custom-designed fish-friendly turbines that rotate slower, thus allowing fish to move safely around or through those dams. Fisheries and Oceans Canada claim that fish passage systems are common when it comes to protecting the aquatic ecosystem. This allows fish to continue their way of life and it reduces mortality. Although hydropower produces electricity without burning fossil fuels, the reservoirs created by dams also generate greenhouse gases like methane and carbon dioxide. When the vegetation floods underwater, it decomposes in low oxygen conditions and releases greenhouse gases. Methane emissions from those reservoirs can be significant at first when large quantities of submerged biomass breaks down. However, according to Natural Resources Canada, hydropower still produces way less greenhouse gas emissions over its lifetime compared to fossil fuel energy. A social issue that hasn't fully come to a conclusion concerns social equity. Some indigenous communities located near major hydropower infrastructures do not directly benefit from the electricity produced. Sometimes they are even forced to pay more for less energy and required to still rely on costly diesel-generated electricity. Some of these communities are experiencing environmental costs without an equal economic gain. However, according to Natural Resources Canada as well as the Canadian Climate Institute, there are new modern policies trying to address this injustice. They are aiming to connect remote communities to cleaner sources of energy and reduce their diesel dependence through revenue-sharing agreements and a better distribution of energy.
These impacts raise serious ethical concerns. In the 19th century, engineering decisions were made without consulting Cree and Inuit voices. They were largely excluded from planning, reflecting deep social inequities and capital greed. Today, solutions are being established. The 2002 Pété-Brave Agreement with the Cree Nation can be used as a model of reconciliation. In partnership with the Quebec government, they established revenue sharing and co-management framework. The revenue was reinvested in the Cree community, building community centers, sports complexes, renovating homes, and paving roads.
Hydropower dam construction raises serious ethical and professional concerns that engineers must address head-on. First, the most pressing ethical issue is the displacement of indigenous communities. Major dam projects in Quebec, like the James Bay project, forced Cree and Inuit communities off their ancestral lands with little to no consultation. This is not just an environmental issue, it's a matter of human rights. Engineers have a professional obligation under the Canadian Engineering Code of Ethics to hold public welfare above all else. To resolve this, projects must integrate free, prior, and informed consent as a non-negotiable step before any construction begins. This means genuine consultation, not just notification. Finally, on diversity and inclusivity, engineering teams must include indigenous voices, not just as stakeholders, but as decision makers.
Hydropower dams are engineering projects which require strong interdisciplinary collaboration and comes with significant environmental and social challenges. To overcome said challenges, civil and electrical engineers work alongside non-engineering professions such as hydrologists and indigenous community liaison officers. Firstly, civil engineers are responsible for designing physical structure of the dam. They analyze water flow and soil stability to ensure the dam can safely create a reservoir and control the flow of water. At the same time, the electrical engineers are responsible for designing the power generation and transfer of the dam. They develop generators and turbines which will use the controlled flow of water to generate electricity. Power transmission lines can then be used to transfer the power to neighboring communities. In other words, the civil engineers will determine how much water can be released, which the electrical engineers can then use to design the size of the turbines and generators. Moreover, electrical engineers may request modifications to the water flow to optimize power output. Furthermore, hydropower dams are often built on or near indigenous lands, thus requiring the presence of indigenous community liaison officers officers. This non-engineering role will ensure the protection of indigenous rights, cultural heritage, and historic lands. To do so, engineers share early design plans with the liaison officer. The liaison officers can then identify the social impacts and negotiate mitigation strategies if needed. By working collaboratively, civil engineers, electrical engineers, and First Nation liaison officers can reduce environmental, societal impacts and create effective and safe hydropower dams.